So that's basically it. And here is the program for today. So first we have the module 0, which is prepare the labs. We just rapidly go through the lab preparation, check if everybody's okay, more or less. Second one is then an introduction from my side to microservices, microservice transformations. Then I talk a little bit about Docker containers. Well, containers basically with Docker in this case. And then I put in a new module, which is Let's Get Real, which basically is why microservices are not always the right solution. And at the end we'll have this container Docker hands-on, for which you downloaded the lab. Yeah, that's basically it. The sources and the documentation, you can find them here. So the first one is where you will find the PDFs of what you have in your training environment within the VM, just in PDF form. Only thing with PDF is that the formatting is not always very good. So YAML files, for example, might be with the space more or less, which makes a big difference. And Yuri tried it, and apparently there's some spaces in IP addresses and stuff like that. So if you can do it locally in your machine, pasting from the demo from the training environment, but you will get the PDF of the courses of the labs. And the PDF of this presentation, you will get them in there at the end of the lab of the course. And the resources for the lab are in my training repository on GitHub. So you can use them locally if some want to do that on a local Docker instance and not in the training environment in the VM. You could do that for today. That would work. For next week, the Kubernetes training will be a little bit more complicated because I set up quite a lot of different things in the VM, so you don't have to do all the work. So those are links. Perfect. So that's the thing. If you have too many people in the call, you see, it's quite hairy to please everybody, but we're doing our best. Okay, cool. So let's jump right in. Let's talk about the labs first before going into the theory. So you will run your own, what I call personal training environment, or PTE, within the VM. So when you start up your VM, you will run a command. We'll see that, and at the end of the process, when everything went right, it will open automatically your personal training environment, where you can click through afterwards and do the labs. It will be the same VM, the same training environment for all the 6 courses. So everything is in there. So if you participate in the other 5 courses, you should be able to use that from the get-go. Good. For the lab, well, you have to download the training VM, set up VMware VirtualBox, start the training VM, log in, and check if it's running. I guess most of you have done that. Just one thing is, if you have this pop-up for the software update, just click it away. Remind me later. We don't need that. It's just between the time that I created this VM and that I uploaded it, and today there has been some updates available, but it doesn't matter. Just click it away. One very interesting thing, I didn't think about that because I thought we were running that just for Switzerland, is if you have to change keyboard, for those who are not familiar with Ubuntu, it's on the top right corner. You just click on that. You can select a keyboard layout or define your own. If you go on show keyboard layout, you can put in your Dutch, for example, keyboard layout or whatever. Then you start the terminal. I guess most of you have done that. It was in the prerequisite. Start the terminal and just run welcome.sh, which starts Docker, which starts Minikube, prepares the networking layer that we'll be using in the security part in 2 or 3 weeks. It starts your personal training environment, and it starts the Kubernetes dashboard. So it will run through. You might have some errors. That's not a problem because some things have not been deployed, and I try to delete them first before redeploying them. Just to have a clean environment shouldn't be a problem. The most important thing is that when Minikube starts, that you don't get an error there. We just had a comment in the Slack that was talking about that, but normally it should come up fine. Then there's a step where it says, please enter your name. You can put in whatever you like, basically, but it would be nice because I will be able to monitor the progress of each participant, given the name. and can see if someone's stuck or something, so I can offer my help. So that would be helpful. Put in whatever you like, but make it identifiable so that we can identify you if ever we need to talk to you. Good, and at the end you should get that, the collector, which is the training environment, and the Kubernetes dashboard in the back. So they should open automatically, and if that happens, you know that everything's fine and you're ready to go. So everybody okay? Will be difficult to check that now. Usually I run those workshops in person with real people in real offices, and usually we have a lot of discussion. Like 25% probably of the whole training is discussions about specific topics. So that we miss here. It's a bit of a bummer, but I mean, we cannot do it differently, unfortunately. So hope everybody's okay. If not, post in the Slack, and I guess you will get a reply. Obviously, I cannot reply right away now, but we can help you later if needed. So perhaps for the training environment, what you have to do first, you will be on the courses tab. Here you have a drop down with the different courses. So the first one will be JTC 01. But JTC, just for information, it's historically grown. It's Journey to Cloud, what we called that before. So you launch JTC 01, which is the Docker course for today. You select begin course, and then you get on the classwork. So in the classwork, afterwards you get the descriptions of what you have to do, how it works and whatever. And once you've done the task, you can select complete. That pops up this little window, and you say press mark to complete. Okay. The complete button might not show instantly. Sometimes it takes 2 or 3 seconds. It depends on the lab, because I could put a delay in there to be sure that that everybody really goes through the labs, but I didn't want to go through that. I mean, if you're in the call, if you take the time, I guess it's in your interest to not just jump over the things. If you want to go back, you can go in the drop down where you see task intro, and you can select another element of the lab if you want to go back or jump around. Thing is, the complete button will give you on the statistics tab the advancement of your course. If you click complete 3 times on the same task because you go back, it will put in 3 check marks. So the platform is not that intelligent yet to detect if you push it several times. So try to be linear and work them through so you get your advancement in a correct way. Afterwards, what I will be having is an Instructor Dashboard. Usually when we're in person in a real office, I share that, I project that to have some sort of competition between the participants. I won't be doing that here, no shaming or whatever, but it will allow me locally just to check if there's people who are stuck somewhere that don't advance. That's the idea. Good. Let's jump in. Yeah, I mean, I told you I'm working for IBM, and I didn't say what I'm doing. I'm what we call a DevOps/cloud architect. So I'm working a lot with customers, helping them understand where they stand, where they want to go, and so on. And when we talk to our customers, we talk a lot about disruption, which is basically about the radical change on how you bring some new product or service to market. I mean, you're all aware, and I'm the first one. I want to be able to sit in my sofa in the evening and order something on Amazon, or do my e-banking from my cell phone. So the whole way we approach the market, or our customers approach the market, has completely changed through mobile, through webs, through whatever. Think of taxis and Uber. Think of hotels and Airbnb and stuff like that. So the whole paradigm has completely shifted, and that's what we say with disruption. Sorry, where I help my customers is to help them understand what kind of digital transformation, or how to structure their digital transformation to be able to not drown in this new world, and to remain competitive. I don't want to go too much into this detail. It's really just for introduction. So what we are seeing is that today most of my customers have a lot of legacy stuff, and if I say legacy, it's not a very nice term, but that's mainframes, that's power machines, that's even client server is considered legacy today. Then we have the whole cloud native stuff, which is containers, which is Node.js, which is Golang, and stuff like that, the modern sexy stuff. And most of the customers I'm working with are really at the beginning, where the little arrow is. So they start experimenting with containerization, but they do that by adding new features or creating new applications. So they don't really touch a lot on the old ones. There are exceptions, obviously, but most of them are somewhere there. So they're starting to experiment. First, they played a little bit with Docker, then they started playing with Kubernetes, and then they found out that it's a really pain in the ass, and it's much more complicated than we think. And really, the idea is to get all to the right. That there will always be some stuff around. You cannot cloudify. Usually, you cannot cloudify your whole IT system. That's wishful thinking. And I was with a customer just on the phone, obviously, just 3 weeks ago, and they said we're going 100% cloud. And they came back after 2 weeks of reflection, said, yeah, okay, no, we understood, we cannot do that. So it's really a whole process of getting there, and we estimate that it will take like 10 plus years for most of our customers to really get to the right and have the whole thing packaged in microservices and so on. So it will be a very long journey. Most of the people I talk to are really at the beginning, and that's why also I'm running those trainings, those labs, to help them understand how they can tackle all those challenges that they're having. So some pillars for this digital transformation is these new processes. So we're talking about this continuous everything's agile, have continuous integration, build, deploy, test, whatever. So that's one thing. We're not going to talk about that. That's the whole DevOps thingy. By the way, I'm thinking of developing an additional courses, and one specifically for DevOps in the cloud native world, with the tooling that's not what we had before, and so on and so forth. So keep an eye on this space. Perhaps you can do that very soon. Then we have the new technologies, obviously, with those new patterns, with microservices, with new frameworks, Node.js, and so on. New tools. I mean, everybody probably today is doing Git, GitHub, GitLab, Bamboo. No, not Bamboo. But what is the word? I don't know. The one from our Atlassian friends. Jenkins, but Jenkins is a little bit on the out now, so it's almost all my customers are using it, but it's not really adopted, or not very well adopted to containers. There's better solutions that can combine with that. Then Docker, Kubernetes, obviously, which goes also in the technology part a little bit, and then cloud. A lot of our customers are thinking about cloud, how to go to cloud. And if I say in cloud, it's not just the Amazons, the IBMs, and the Azures or whatever, Googles of this world. It's also private cloud. So cloud meaning here just dynamic infrastructure that you can provision on out of a self-service catalog on demand. That's the idea. So cloud is really can be on-prem in your data center, or at home, or in your basement, or can be provided by third parties. So cloud in the large sense. So a first step for the whole thing is microservice transformation. So what is a microservice? Basically, microservice is a single function module that can be deployed and operated independently. So you have your huge hunking, what you call monolithic application, that you will cut down into small pieces, and each one of those pieces has just one function. I'll be talking about that a little bit more in detail afterwards. And that helps us accelerate delivery. I will explain you how we achieve this. So the idea is to go from something like that, where you have one big hunking database and one big hunking application with the UI, business logic, everything coupled together in one application, to something that looks like that. So we have one component or one microservice, that's the UI, or even several that compose the UI. Then you have microservices, for example, a microservice that gives me that handles the users, so I can get the list of users, I can create a new user, another one for credit cards, another one for seat reservation, doesn't matter. Okay, so we have a more in-depth look afterwards into that, but that's the idea. Go from something monolithic, and I'm not saying it's bad monolithic, just to be very clear. I'll talk about that in like 30 minutes or something. But to take advantage of this split up architecture to be more agile and put in place DevOps and continuous transformations. So the idea here, that's an example for a book flights application. So the idea would be to have different microservices. So each one of those is a microservice. So I have one for book flights, which itself will use afterwards one for update customer, a microservice for adjust inventory, another one for seat allocation, and so on and so forth. Thing is, and I will be talking about that afterwards, and you see that slightly shown here, is that each one of those services can be deployed separately, can fail separately, and can be scaled separately. So imagine you have a I don't know, an online portal to selling stuff, and before Christmas you have an action, you have a special action or something, special rebate on certain products. You might be able to scale up just this one part of your application before Christmas, and then scale it back down when Christmas is over. So that's the idea, to have completely independent elements. So what are the key tenets? So we take a big hunky monolith and break it down into small services. Each service is optimized for a single function, and usually those services, and again I will talk about that more in detail in the third part, they communicate either via REST API or message brokers. So I'll be talking about that. So we really need clearly defined APIs between those services for it to function. So we can have per service continuous delivery, that's the cool thing, and we can have per service high availability. So those are more or less the key tenets that you have in a microservices environment. What are the advantages? Obviously, we can develop them independently. So if you have one team that develops one component and another one for another component, a team can deliver, for example, every second day, and the other team can deliver every 2 weeks. Okay. And given that we use REST interfaces or message brokers with defined APIs, they should be, in a perfect world, obviously, it's not always the case, but usually it should be the case, that they can release at their leisure. So at the rhythm that they want, they can develop completely independently without explicit dependencies. So you can have single small teams, and that's the basic idea of the whole DevOps. Well, that's the buzzword, but the whole continuous agile development processes. You want small, what we call 2 pizza teams that you can feed with 2 pizzas. Well, it's American pizzas, so they're pretty big. So I mean, I guess you can have slightly bigger teams, but small teams that do their thing on their responsibility, on their microservice. So they can have their own timetable. I always say that. It scales and fails independently. I already talked about that. They can be developed in different languages. So that's a cool thing. So perhaps you have one team that is very familiar with Golang, another one with Node.js, and another one with Java. Why not? You can do that. I will be talking about the drawbacks. That's the nice thing that we can have. But obviously it becomes complete anarchy if you have 20 different teams, and each one of those teams uses a different technology that can get quite hairy afterwards. But we'll talk about that. And each one of these microservices manages its own data. And I will be going in the third part more into detail about this part, because that's very important. And a lot of people I talk to think they're doing microservices right, and they do it completely wrong. I come back to that later. Okay, so the rules. I don't want to go really into detail. You have the links, by the way, where I found the whole thing. So don't code to specific topology. Don't code against Ubuntu or Linux or Windows or whatever. So we need this portability that so that we can transport the whole thing. So that's where the containers will be coming in. We cannot assume that the local file system is permanent. So we don't save state to the file system. We need mechanisms to keep state and to keep our persistent data somewhere, but not on a file system. Because if your microservices goes from one machine to the other and the file system isn't there, it doesn't have the data anymore. Same thing with the session state. We shouldn't keep session state within the application. We shouldn't log to the file system. We log just in the standard out or something, so that we can digest that afterwards in the mechanisms that we will be seeing in the Kubernetes part, so that we can do log aggregation throughout the whole system. So don't assume any specific infrastructure dependencies. So don't assume that certain DLLs or certain libraries or whatever are installed. That's, again, we're coming to that with containers. That's the nice thing about containers. You almost don't have to care about that. Don't use infrastructure APIs. So APIs, not APIs in itself, but APIs that are really off from the OS itself, because you have to be independent from that. Don't use obscure protocols. Well, that's a funny one. Self-explanatory. Don't rely on all specific features, and don't manually install your application. So the whole thing should be able to be automated. So those are more or less the rules. And I don't know who's familiar with the 12-factor app. That's something that has been posted quite some time ago, where we talk about what you need to transform your application to microservices. Now, sorry, I thought I had an animation on that. What's very important to understand is the 12-factor apps is really to have this independence and so on and so forth for microservices itself, but it's not in 100% the approach or the recipe to develop cloud native applications. Okay, so I just mapped them to on the left some of those factors to what we can see in cloud native applications, like horizontal scaling. That's a terrible word. Immutable deployment, elasticity, and stuff like that. So they map back, but there are some that are missing, and there's one of my IBM colleagues who wrote a very interesting article about the 7 missing factors from the 12-factor application. You get the link to Medium down there. I won't go into detail here. That's something that I might put into one of the additional labs and trainings that I'll be providing. That's very, very interesting to talk about observability, schedulability, and stuff like that, which are missing from the 12-factor apps. So if you get that, usually you have sort of a recipe on how to do microservice. But that said, microservices are freaking hard. It's really not easy. If we implement them correctly, it's really cool. It works like a charm. But if we implement them incorrectly, it gets even worse than what we had before. So if we want to do microservices, we really have to be careful and to be sure that we architect the whole thing correctly from the get-go, from the beginning, and that we make sure that we respect more or less those factors and the key tenets of a microservices transformation. And we'll get back again in some minutes when in the third part where I talk about the reality check. So, but we're getting ahead of ourselves. And before diving into the Docker part, are there any questions? So I don't know. Can you guys, Pascal, Yuri, tell me if were some questions in the chat that I should address?
There was one. I think you partly already explained it a bit, but the term cloud native. Can you give like the definition of it and explain it?
Yeah, well, it's a bit the same as with DevOps. When I talk to customers and ask them what DevOps is, they give me 10 different customers give me 10 different definitions, basically. So cloud native means just that you developed your application or transformed them into a technology stack and architecture that can be easily deployed on the cloud. So meaning containerized, meaning serverless, meaning stuff like that. Now, one interesting thing, and I just saw that I forgot to put this slide in, because I have a very interesting slide about cloud native transformation, and I've experienced that some time ago. It was over a year, 2 years ago, I guess. I started with Kubernetes like 3 years ago, so it must be 2 years ago. I was discussing with a customer, and he told me, "Okay, I'm starting to adopt Kubernetes. So what I'm doing now, I'm taking my monolithic application, containerize that, and deploy that to Kubernetes." And I was just like, why would you do that? That's completely stupid. You don't have any good thing coming out of that. You have to do microservices transformation first. And he told me, no. What I want is through the containerization of this application, I already have, and we will be talking about that in a second, immutability, because a container, you put your code in there, And what you have in dev, what you have been testing in test, is exactly the same guaranteed that you will put in production. So he told me that's the most important thing for me, is that I have this immutability. I develop the thing, close the door of my container, and then transport it through my whole ecosystem. Second point was, if I do that, I have exactly the same delivery and development and test pipeline as for my cloud native, my real cloud native stuff, my new developments that I'm doing. So that are really microservices and whatever. And I can really use the same pipeline for all the teams. So I can standardize on the pipeline, on the delivery process, on the testing process for my older / monolithic applications and for my new ones. So the next step afterwards would be to say, okay, now I have some of those applications that are still huge and difficult to maintain. I can then start, when everything's automated, the pipeline stands and everything is peachy, then I can start cutting that in pieces and create microservices out of that. Because creating microservices, you imagine, you have to put energy in there to reduce the entropy. That's physics. So you will have to have a budget, you have to have the management buy-in and whatever to do your microservice transformation. That's not something that the development team can do just like that in an afternoon. So I think that in the end, it was a good idea, or it is a good idea to say, okay, let's just start with the beginning. Let's take our applications. Don't do too much of microservice transformation. Let's tackle that later, but just standardize our stuff and go with containers and do that later. That's exactly the thing. So if there's no other questions, let's go to containers. So that's a statement. Why is that? Because it's a standard way to package your applications and all its dependencies. And that's the really important part. And that we can isolate the difference between applications and platforms that it runs on. So that's probably the most important slide. If you have understood this slide, basically you could drop out if you don't want to listen anymore. A container, I'm not talking about Docker yet, because containers can be other things than Docker as well, gives me perfect separation of concerns. The development side, just worried what goes into the container. So the code, the libraries, the packages, the apps, the data, whatever. So those guys will define the container, what is in there. And then they just close the door and it's immutable. So you cannot change that anymore. Then the container goes to the operations guys, and the operations guys, they don't give a damn what's in the container. What's interesting to them is what's outside. So how do I make sure that it runs in a stable way? How do I do logging, remote access monitoring, all that stuff? So they are operating the whole thing. And the funny thing is, this separation of concerns helps us to build really strong DevOps teams or continuous delivery teams, if you want, because they know each one of those knows exactly what their responsibilities are. So that's a really cool thing about that. So development puts the stuff in, closes the door, operations runs it. And as it said here, all Linux servers look the same. So for the development guys, the server that it will be running on look exactly the same. Heck, you can run Docker containers on Windows today natively. Afterwards, yeah, I won't go into that. They did a tremendous job, Microsoft. That's not a problem. But those containers, and here we go rapidly into the history. They have been around like for forever. In '79 with change root, it started. Then we have C groups that help you make sure that the process cannot allocate more than such and such memory, and so on and so forth. Then came Linux containers in 2008, which was more or less the predecessor. I probably get killed for this statement, but anyway, of Docker. And then came others. So we had Warden, then came Docker, then we have Rocket, which is out again. No one uses that anymore, so it's deprecated. Then we have Garden Run C, which is really the low-level runtime, and the new kid on the block, which is Container D. And one dot that's missing is Creo, that has been developed by Red Hat, which is basically challenging Docker, because Docker, it works very well, and those guys did a superb job. putting this stuff together so that someone like me can use it, because otherwise before the concepts, the technology was around, it was just absolutely nightmare to use that if you're not the absolute super Linux hacker. So Docker really made it easy to create containers, to run containers, to store containers, and whatever. Now the problem with that is that Docker has quite some closed source stuff in their solution. Even if most of it is open source, there's some closed source stuff. So Red Hat have said, okay, let's do something. And as we got something that's called OCI, that's the container standard. So the format and how the containers are stored and created and everything, that's the format itself is a standard. So they built something called CRI-O, CRI-O, and which is completely open source and which allows you to run containers. Then you have a second tool called Builder, which is basically the build tool for Docker containers. Now, the good thing about that is that Docker is just a huge running daemon with sudo access in your environment, which makes it a bit clunky, which makes it not very optimized, and which might present some security issues if you don't do it right. So what they did with CRI-O is just take the whole thing, re-architect it, and they're completely compatible. So containers that you build with Docker can run on a CRI-O. And if you take, for example, Red Hat OpenShift today, the platform, the Kubernetes platform, is running on CRI-O and not on the Docker engine anymore. So it's going forward. And as you can see, there's a lot of stuff like C groups, change root, and stuff like that that are native to Linux. So I'm circling back to Microsoft. So they had to create an abstraction layer because Windows just doesn't know those concepts mostly. So but today you can do that. You can run Docker on a Mac. You can run Docker or containers on a Windows machine. It doesn't matter anymore. It's just that it's really completely Linux native at the base, and on Mac and Windows we have to jump through some hoops to have it run. Good. Okay, so why would I use containers against VMs? If we take a typical VM stack, I have my infrastructure with a hypervisor, be it vSphere or OpenStack or whatever, and on there I have my VMs with a complete guest OS and with the bins and the libraries and the application on top. So I might have a complete Ubuntu that's running, I might have a complete Red Hat Enterprise Linux that's running, I might have a complete Windows Server 10 that's running. And obviously I have pretty high overhead because I'm running those on parallel and they take some space in there. But I have very high isolation between the VMs because each one of those has an own OS. If I look at containers, again, with those concepts that I talked about before and some more, every container, every application is running as a process on the host system. So you don't have this guest OS anymore. So you don't have the overhead of this guest OS. They are running natively on the host system. And if you look on the host system, when you started some containers, if you're administrator, if you're sudo, if you're root, you can see all of those containers running, all those processes running on your host system. So that's possible. However, the process itself, for example, application 1, is running on a system where there are a lot of other processes, but it cannot see them. We have complete isolation on a container level, on the kernel level. It's really a shared kernel, shared operating system, but they're completely segregated, completely isolated through those concepts like change root and stuff like that. So obviously, a lot less overhead. It's much easier to do the burstable compute and memory, whereas the VM have to shut it down, put more memory in, and so it's a lot less dynamic. Now, that's my favorite example. So if you take vases with the same volume, if you put big balls in that are the VMs, let's say we can put 4 VMs in there, and we have a lot of space. So usually usage of VM solutions is well, it depends. I had customers who are at 50%, which wasn't very good, can go up to 60, 70% max, and 70% being really top of the line. And then if you put on the other side those small containers, and they even much smaller than the VMs, I should make them much smaller still. You can see there's a lot less of air of unused capacity in this solution. So here we can go up to 85–90% of resource utilization. So that can be interesting as well on a cost level, to be able to better use those resources. So that's one of the major advantages of containers. Not talking about the rest, the immutability and so on and so forth. We're going to that afterwards. So globally advantages, they are portable. Again, they are, it's an image, it's a container, doors is closed, everything's in there. And as it's a standard, this OCI, I can run them on Ubuntu, I can run them on CentOS, I can run them on Fedora, I can run them on Red Hat Enterprise Linux, I can run them on Windows, I can run them on Mac. It doesn't matter. They're completely, we abstract away the infrastructure and the OS that's underneath. As long as we can run containers, Docker or Cryo or whatever, it runs. They're easy to manage because they're small parts, small chunks of an applications. They provide, and that's exactly that, just enough isolation. Again, VMs have better isolation than containers, but up to now there were not that much problems with isolation. So I don't think there was a big major problem with that. So Yuri tells me break. Can we go just a little bit farther to try to wrap up this part?
Sure, yeah. Just keep it in mind that.
So yes, I keep it in mind, and if we don't do coffee break in 5 minutes, just shout at me, please. Okay. So use hardware more efficiently, obviously, and the immutability, which is probably one of the most important parts. You don't get this works on my machine syndrome anymore. I mean, we developers, and I have been a developer for a big chunk of my professional life and before. Yeah, it works on my machine. What the hell are you production guys doing? It works. What are you doing with my beautiful code? I mean, you know that. And then we have the ops guys who are saying you don't understand what the load balancer is and what the database index is and whatever. So that's exactly the problem that we have with DevOps. But I'm going down the rabbit hole. So thing is, I pack it in, can deliver it, test it through the different test stages, and put it into production. Good. Okay, let's take a break now. Then we talk about the different components. 5 minutes. Usually what you do when starting with transformation is that you do what we call the strangler pattern. Okay, you strangle your application. So you start taking your monolith and you start taking out chunks at the outer parts of the application. So for example, say the seat reservation, what we had before. So that, for example, you take out the seat reservation and create that as a microservice. So you start taking away bits, chucking away bits from your monolith until you get like a big black hole in the middle that you won't be able to decompose any further. And that's why I said in the beginning that usually it's very complicated to do a complete transformation, cloud native transformation. And what you would do, you would probably keep around this core system and still run it in a VM, but then use this VM perhaps to put it into public cloud or use it in a more dynamic way. But very often it's not possible or very, well, it's very costly, let's put it that way. It's not that it's not possible, because you have to see, you can decompose it obviously, because you have to rewrite the whole thing afterwards, the whole core part. But often it doesn't make sense to rewrite this part because it's too costly. So you have, on one hand, you have the advantages because you can deliver faster, you can adopt those nice DevOps processes and whatnot. But on the other hand, you have cost, and that you have to find the balance. And what we're usually doing, our services guys at IBM especially, they are very used to that and do a mapping of your application landscape and then help you decide which applications are business critical, which ones bring the most money for the firm, for the company, and then you start doing matrices and prioritizing the whole thing. So that's usually how you do that. But microservice transformation is hard. It takes time. It costs money. It's not just something that you do because it's cool, because the technology is cool. It's really something that you have to think about before. Good. So I think we go back into the Docker part. So a container is what we call the smallest compute unit. So a container is a running instance with one process of one microservice, if you like. Okay. A container, it doesn't go further, is created from an image, what we call. So the image, and that's where it gets a little bit confusing. When I said before that we build a container, we close the door. We're really talking about an image here in Docker or container terminology. An image is like, how do you say that, Yuri? Kuchenförmli. It's like a pattern or whatever. You know, when you do your Christmas cookie, a cookie cutter. That's it. Your Christmas cookies. The image is the cookie cutter, and then you cut out your containers, and you can cut out as many containers as you like from this image. So that's a bit the analogy. I guess it's not a very good one, but I haven't found anything else yet. What I have to say is down here you have one process per container, and that's extremely important concept. So your container should run one process only. So that might be a web server, a Tomcat, or a WebSphere, or an Nginx or whatever, or a database engine like MySQL or MongoDB or something. One process per container. That assures you that they stay simple, that isolation is guaranteed, that we don't have security problems, and that they're easily maintainable. So when I started with Docker, like 3.5 years ago, or even more, well, when it popped up, I was always thinking, okay, now I have my container running with one process, but how, for example, can I SSH? How can I access what's running in this container? I wanted to look around, debug it, and so on and so forth. So there are ways to put several processes in a container. They're not very nice, but you could do that, but don't do that. Because typically SSH, you don't need it. What you would do is there's a Docker command, docker exec, and you will be doing that in the labs, where you can attach to a running container and get an SSH shell, an executable shell into the container. So I just saw a question, sorry to interrupt. Are we going to get the presentation slide? Yes, they will be on the links that have been shared. They will be on my GitHub as PDF format. Okay, then where was I? Okay, image is cookie cutter, containers are the running instances. Now, another concept is what we call the image registry. So they store the versions of the different images. So I can have, for example, my web app, and I can what we call tag them with versions. So I can say I have web app version 1.0, then web app version 1.1, web app version 2.0, and so on and so forth. So that ensures that that my application, when I deploy it, when I create it in dev, for example, I have a new version 2.1, I label that, so I create the image, I label it with v2.1, and when I deploy that 2.1 into production, I'm sure that it's the same. So it goes with immutability. So it's just a way to handle and make sure that the immutability is guaranteed. Okay. There's a tag that's called latest. So when you push or publish an image into the registry, the latest one always gets a tag latest. Please don't do that, don't do that. Don't use that. I had customers, I've seen them be using deployments where they said, okay, I want to deploy my web app latest. You don't know what version you will be deploying, because if a developer has checked in or published a new version, in the meantime, you will be getting this. So always use explicit tags. Those can be version tags. You could add the -dev or -prod or whatever. It doesn't matter. It's a string basically. So tag your images and always use tags. You can use latest in your development environment because you're working on the local latest image, but never use that to go further into test or production. And I talk about that in the security part as well, because that can open huge security problems in production afterwards. Because you have immutability, but you don't know what you're deploying exactly. Good. Okay, components. We had that images, containers, the registry, and then obviously the whole thing, at least for this lab and this example, is running on the Docker engine. So how do I create a Docker image. Basically, I get what we call the Dockerfile. I go into detail in a second. The code, the configs, whatever makes up what I want to put into the container, into the image, and close the door afterwards. When I do a Docker build, it gets stored in my local Docker engine. It's not a registry per se. I put registry and I should put it in air quotes, basically, probably. It's just stored on your local Docker engine. So it lives on your machine only, okay? So what is this Dockerfile? So basically it's a recipe, if you like. How do I create? What are the steps to create my image? What do I want to do? And if we go a little bit more into detail, you have directives like from, run, copy, entry point, and so on and so forth. And then you start your Dockerfile, and you always start with a from. A from tells you what we call base image are we using. So if you go on the Docker Hub or Quay or whatever, you can see that there's, for example, an image, a base image for Tomcat with JRE8. There's base images for MySQL. There's base images for Ubuntu, for CentOS, for whatever. Okay. So usually you start from a base image where you already have an Ubuntu in there, or already an Ubuntu with a Tomcat installed for this example, or whatever. The ones that are just Tomcat and nothing before, so no path, those are the official vetted images that you can pull from Docker. So they're security scanned. They're the official images from the Tomcat guys. Or if you use Ubuntu like 20.04, you get the official image from Ubuntu that has been security checked. Afterwards, obviously, you can use your own base image. For example, if you have, I don't know, you're using Ubuntu and you use some fancy, I don't know what, web server or whatever with specific configurations for your firm, you can always use that. That's not a problem. You can use any image that exists either on your local machine or in one of those repositories as a base image. So there comes in the concept, just I didn't put it in there, what we call, that's the new kid on the block, is multi-stage Docker files, where you first build the basic Docker file which generates, as I said, for example, a Docker file with a web server with certain things, and then it automatically takes the one and puts your application in there afterwards. So that's the base image. Then we can run commands like apt-get, yum, also install stuff in there. We can move stuff around, copy, and whatever. So all the commands that are available, for example, in Ubuntu, if you take an Ubuntu base image, you can use them in there. Then you can set environment variables. Those are variables that can be used by standard, and well, they will be available within the operating system as standard variables. They can be overridden. So when you run a Docker container, you can override those environment variable, for example, my name, and you can put in Nick, for example, and then the Docker container that's running will have this environment variable set to Nick. So for example, for database connections from a WordPress or whatever, doesn't matter, where you have to put in an IP address or a port or a name or a path or something, we will do that with environment variables. Then we have the add keyword, the directive, where you can add stuff from your disk to the local, to the image that you're building. So the first one, we're adding, for example, the web XML file to the Tomcat configuration locally within the image. And in the second one, which is copying over the WAR file, so the web application archive file, which contains the application that we've built before. So here you can see also, like my dear client back then did, they just had a huge hunking WAR file that they were encapsulating like that, and they copied it in. Then they had a container that was like 1.5 gigs in size, which is huge, but it works. So that's that. And then the last one, you have the command that runs the command that you want to execute when you run the server. I'm getting back to that because there's some confusion. It's pretty technical what I'll be saying afterwards, but there's a difference between command and entry point, and I'll illustrate that. So to build your Dockerfile, what you'll be doing in the lab, you just say docker build -t, then you give the name of the image, and then you say, you specify the Dockerfile. Usually just put in a point at the end. You don't have to specify /Dockerfile if you don't want to. Like that, it just takes the Dockerfile that you have in your directory. Important thing, the D is uppercase. That's the standard that they define. So the D is always uppercase. Now here for this example is perhaps not the most intelligent one. If I do it like that, it will generate an image that's called my image latest. So I could have put in my image and then the, what's it called? Columns? No. Columns? Doppelpunkt. Before the latest. Yeah, anyway, and put in v1.2, for example, or something. So that's how you would normally do that. So what happens exactly when I build this Docker image? What Docker is using is what we call the layered file system. That's extremely important to understand because it's very, very, very efficient. So what happens when I say base from Tomcat, it gets this base image from the registry, and then we start building on that. So my first command would be run apt-get. So it creates a new layer on top of that, just with the contents of the files of the stuff that has been created when I run this command. Then the next one would be the env my name, creates a new layer. Then I have the add web.xml file, and then I would add the war file, and then I put in the command. So it's really like a layered cake of the different commands. Now you can imagine, and I won't go into detail, we could perhaps do that in the next training. You can optimize the hell out of that. Because if you have like 5 runs, run apt-get, then run apt-get upgrade, then run apt-get install, run up apt-get install, and so on and so forth, it creates a new layer each time, which takes up place, which makes your image bigger. That's why in this example, you can see we have run apt-get update and apt-get upgrade, which runs them in the same layer. So for testing purposes, usually you would put them separately. And once it's working as it should, you put everything together. And there's some cool things that you can do with not using cache for apt-get, for example, and stuff like that to keep them down. So perhaps as an example, when I created my first Docker image back then, it was like 800 megs in size. And after doing just a little bit of optimization, it went down to 180 megs. So more than 4 times smaller. It's not important if you have it locally on your machine, except that it takes up space, but it can be important if you want to download that afterwards from a registry, if you want to deploy it on other hosts, on other machines, on other Kubernetes clusters. Each time it has to download the whole thing. So it's a pretty big difference between downloading 100 megs or 50 megs and the gig for the image. Okay, so just my 2 cents. Now, the other cool thing with that is that we can reuse the layers that we already have. So if I just modify if I have 2 Docker files, one with web 1 and one with web 2, and my war file and your war file, it will keep the layers that have already been created because it's putting hashes in there. So it knows exactly what has happened in this. So it's a clear identifier. So that allows us to reuse the whole thing. Again, it makes the images smaller and makes it faster to pull them down from the registry. Because suppose if we have already pulled the right part here, the web 1 part, and if we pull the second one, it will pull just the 3 top layers because the other layers are already present on your system. So again, extremely flexible, very optimized for the time it takes to download, for the time it takes to build, and so on and so forth. And one thing for the build, when you do the Docker build, perhaps then you could just go back one. Sorry. If you have things that are changing often, like for example, add your war file. If that's the thing that you're changing regularly, and the rest doesn't change, put the stuff that doesn't change first. Because if you build the whole thing and those layers have already been built, it skips over it. So it won't rebuild the whole thing each time. So it will just build this layer and this layer. So you can optimize also the build time for the containers by putting them in the right way and putting stuff that you're changing often at the end of the Dockerfile, if possible. Good. Now let's talk about how we run the whole thing. So we can run that on the local Docker engine from the local registry, if you like, so from the local storage. So what happens when we run a Docker container is that it's basically an image with just a writable layer on top of it. So it creates a new file system layer. And for example, if the the container generates log files or whatever, they get written into this top writable layer. Okay. Now you understand as well, if you kill the container, if you stop it and kill it and restart a new one, this writable layer is gone. So you don't have persistency. So if you create a container, do something, kill it, and restart it, this data is gone. That's why it's extremely important that we think, and now getting back to the microservices paradigm, if we create microservices, the microservice itself should not keep state and data within the container. It has to be stored outside of the container to persist it, as we call that. Okay, so like that, the container can die and restart and die and restart, and the data is still there. Worst case scenario is that you have a customer or someone who's working on a web app, or who's in the entry form of a web app, wants to order something, the pod crash, the container crashes, comes back up, he has lost what he was putting into the form. That's the worst case scenario. And as we will be having not one container, but usually tens or hundreds of containers for the same functionality, if we have 100 customers on 100 containers, if one goes down, there's one customer who just lost perhaps 3-4 minutes of his life because he has to re-enter the data. So it's pretty solid and robust, the whole thing. Now, once we've built the whole thing, we want to store them somewhere, and here we're coming to the registry. So here we talk about Docker push and Docker pull. So if you look, perhaps, yeah, I should invert that. If you do a Docker images command, you will be doing that. You get all the images that you have on your local machine. So the local, again, Docker registry, okay? Now, if you want to work with a hub, sorry, no, I'm in the run part still. Oh, sorry, I mixed up my slide. Sorry, let me go over that. I'm coming back to the push and the pull afterwards. So the Docker run, usually say Docker run, and then basically the image with the version or the latest, if ever, that you want to run. Now you can put in some options. I just put the biggest one in there. You can have a look at the Docker documentation. It's not rocket science. So with the -e, you can override those environment variables I was talking about. -d means that it runs as a daemon. So it will start in the background and you won't see anything. If instead of -d you put in t and I think that's terminal and interactive, you can say my image /bin/bash. It will start a bash, a shell within the Docker container, and you will get direct access. But if you stop it, this will go away. So if you do Control-C or exit or anything, the Docker container will stop. So that's usually not the best idea. It's good for debugging, but usually not the thing you want to do. Okay, so let me talk rapidly about comment versus entry point. So if I define in my Dockerfile comment echo hello world, or there's a airport missing, and then you start it, you say sudo docker run and you give it the image name, it will output hello world, obviously. If you run sudo docker run the image name host name, it will execute host name in this Docker container, and it will output your host name. Okay, so command CMD can be overridden. The command itself can be overridden, so you don't have echo anything, but it will be replaced with host name. And entry point is if you really want to make sure that people cannot run security critical stuff or something. So again, if you run it normally, you will get hello world. If you say sudo docker run host name, it will say hello world host name, because it just appends what you put afterwards to the echo command, to the command that you're running. Okay, so that's the difference. And you have the link here if you want to have a look at a little bit more in-depth explanations. Yes, now the registry. So I have inverted them. Sorry. So what you usually be doing if you want to publish, and you'll be doing that in the lab as well, you would say Docker tag my image 1.00. So I say that's my local image, my image 1.00, and I put in a tag called my registry / my image 1.00. So this my registry can be Docker, this can be Quay or whatever. For Docker, if you have an account on Docker, mine's Nicholas Hirt, for example. So I would just put Nicholas Hirt / my image 1.00, and it will push it to Docker if I'm logged in. Okay. So if I do the Docker push afterwards here with Nicholas Hirt, it will push it into my Docker Hub repository. So that's basically your space, your account in the Docker registry. And that's why I told you most of the images in the Docker registry have something here. It can be my name, it can be something else, where people publish their images. If you don't have this part, as I said, it's the official Docker images like for Ubuntu or Tomcat or something. Okay? And then you can do the invert thing, Docker pull, so you can download this image to your machine. And you can see here an example when I say Docker pull Postgres, for example. It tells me, okay, this layer here already exists. So that's perhaps in Ubuntu or something that exists already. So I just pull the rest of the layers that I want, and then you have it on your local machine and you can play with that. Okay, so you build your image, it will be stored locally. You can tag your image with registry information, then you can push it to the registry. You can pull it back down if you like, and at the end, you can run it. Now, if you do a Docker run, just small information of an image that is not present on your machine, it will pull it automatically. So Docker pull, I think I have used it like 10 times in the last 3 years. So you don't use that very much. So just do a Docker run with the image and it will pull it automatically before running it. Good. So the basics, we have seen that. Public registries are Quay, hub.docker. There are others. We use the registry that's built in Mini, for example. You can enable that. There's a lot of other ways to run registries for free locally. You can run that just on your Kubernetes cluster or whatever. Okay, good. Recap before we go into the last part. Containers are not VMs. No shit. That's obvious, I guess. The benefits that come out of that is efficiency. We've seen that. Portability, again, they are almost completely insensitive to the underlying OS. Okay. Now it's up to the OS to provide and make sure that it's really completely independent. There's one example, for example, if you want to run .NET application, containerized .NET applications, there are two flavors of that. You have what we call .NET Core, which is a stripped down version of .NET that runs on Linux. So it runs on standard Docker or Kubernetes clusters. And then you have the .NET flavor, which provides more or less the whole functionality that our customers have, my customers have in their existing .NET applications, and those cannot run on Linux. So you have to run them on Docker for Windows. Okay, so out goes our portability out of the window. So there are some cases where it's not 100% portable, but usually in 99% of the case it's portable. So you get your MySQL or your WordPress image. You can run it on Mac, you can run it on Windows, you can run it on every Linux flavor. It doesn't matter as long as Docker or any runtime is running. Consistency, obviously, we talked about that. Now the new challenge is that production apps will be dependent on open source projects because almost everything is open source. And either you believe in it or not. Okay, so I won't make a statement about that. I'm a big open source fan, but that can have its own challenges because open source has a sometimes different pace of evolution than your projects or whatever. Okay, existing tools might not be sufficient for containers. So perhaps you need new tooling, you need new ways of doing your pipelines and so on and so forth. And very important, and that goes with the microservices thing, focus on the business objectives. Don't do microservices / containers just because it's fun, technically. I mean, I've been doing that. I'm the first to have done that. But usually there must be a business need and there must be a good reason why you would want to go in the microservices / containers direction. Okay, good. Questions? I have to speed up a little bit, otherwise you won't have time enough for your labs. Let's get real. So everybody's talking about microservices, and I already hinted a little bit that it's not already the same thing. Okay, sorry, I get the thing Tuesday instead of Wednesday. No, it is on Tuesday evening. We have a well, 3/4 of an hour, 1 hour slot for preparation, and the labs, the training will be as today, Wednesday at 2 o'clock. Okay. And if the VM is already set up, yes, you just need this VM. Everything, you have everything on board. Unless I be doing some upgrades in my training repository, but it's highly unlikely. So you will have everything. You just restart up your VM. So you don't shut it down. You just save the state, and then you restart it next Wednesday at 2 o'clock, and you're good to go. Good. Okay. So what the good thing about microservices? So I won't go into detail. We talked about that. They scale separately. We have isolation, good enough isolation. They can be modified without compromising the whole system. They can go down without tearing down the whole system. If your monolith goes down, production is at standstill. Idea with microservices that if your seat reservation goes down, people just cannot reserve seats, but they can do a lot of other stuff still. Okay, you can use the languages and the frameworks that best suit the purpose of your service, and they're natively ready for CaaS and PaaS, for container as a service and platform as a service. So that's the good. The bad, well, you have added management complexity. You go from one monolith to hundreds of containers usually. Okay, more complexity. You need the expertise required to do that, because you have to be able to build the containers, run the containers afterwards probably in an orchestrator like Kubernetes. Your ops guys must be able to monitor the whole thing. We'll be talking about that next week, and so on and so forth. So there's new expertise that has to be acquired in the teams. You have no or reduced benefits if your application doesn't need to scale, or you don't want to put it on cloud or anything. If you're happy with the status quo, don't containerize it. Don't adapt microservices. That's just, there's no need. And you need more robust testing. Imagine your monolith. To test it, you can have end-to-end tests. You can have all the tests go directly onto the monolith. Now, if you split your monolith into 30 different microservices through 30 different APIs, you have to test each and every one of those APIs before doing the end-to-end test as you did before. So you need a slightly modified and more robust testing strategy, which is costly, obviously, and needs transformation and change. And then downright ugly, you might have a pretty high initial investment, because you have to redevelop some stuff. You have to do this triangular pattern things, and so on and so forth. I'm not talking about containerization. I'm talking about microservices here. So again, you can containerize the whole thing without transforming them into microservices in the beginning, and then start doing that later. Okay. And the thing is, you will be getting non-uniform application design, because if each team can use its own technologies and languages and databases and whatever, you will get anarchy, basically, technically speaking. So there's a fine line always between how much freedom do we leave them, and how much standardization do we still impose on those teams. And if you look DevOps mentality, it says everyone should be using what they want, which is half of the truth. Because imagine one team is using MongoDB, another team is using Oracle, a third team is using Microsoft SQL, and so on and so forth. You will be needing licenses for each one of those. So you have to handle the license things for and acquiring licenses and measuring license to be compliant, whatever. Sometimes you need different skills. So if one person wants to change from one project to another one, it might be complicated. So there's really a fine balance to be found between the two. Leave them as much freedom as they want, as they need, but try still to standardize. And usually we're standardizing on the platform itself. So typically, as IDM bought Red Hat, we're talking about OpenShift, but usually we recommend to put in OpenShift as a container platform, because it runs on OpenStack, on VMware and whatnot in your local data center, and you can get it in a managed way on IBM Cloud, on Azure, on AWS and whatever. And here again, we have this abstraction layer when you can run your stuff and you don't mind. You can put it in your data center on your cluster, or you can put it in the public cloud on your cluster on Kubernetes, and it just runs, more or less 99%. Okay, so that's the idea. So try to standardize some things, and again, that's a discussion that we could go on for hours. With leaving them still quite a lot of freedom of what they want to do. So usually what we recommend our customers is that they decide for one or two SQL, so relational databases, one or two non-SQL databases like MongoDB or stuff like that, and they stick with it. So often we have a customer using Oracle and Postgres, for example, and MongoDB and something else. Okay, so try to standardize a little bit. Okay, good. Overload of documentation. Obviously, you have to document each and every component. And having been the developer for most of my life, we don't like writing documentation. And we don't. And once it's written, if we have to write it because we don't get a bonus afterwards at the end of the year, we don't maintain it. So 3 months afterwards, documentation has been written. It's out of date. So we have a lot of documentation to write, and it can be quite challenging to keep that up to date and easily digestible. So those are the things. Again, when implemented incorrectly, it's a nightmare. So plan ahead, get management buy-in, get the costs, the cost assigned, and so on. Do an architecture review. Think exactly what you want to do. Then you can start on a small project in a DevOps way. Take a small project, containerize it, adopt some new technologies, some new tools, and so on and so on. Please fall on your face. Please fail, because you have to fail to do it better. Be agile. Go back and reassess and do it better. And that's exactly how we do it. And once we have 2-3 projects that are working like that, we can start pushing it out, showcasing the whole thing, and try to roll it out. Okay, good. Question, AWS would be nice. Running the whole thing on Amazon. Was that the question? I'm waiting for the response. And then create microservices from a single capability of the microservice.
Yes, it's a question. It's a question that has been posted on WebEx. So
okay,
if my PC is not powerful enough to run a VM, can I run it on Amazon?
Okay, ensure microservices no depends to the monolith, configure proxy, whatever. Is the recommendation how to ensure that when I'm not the developer of anything, or when not developed here? Yeah, that's a problem. That's a problem. When you buy off-the-shelf software, very often they don't even containerize that. So you're stuck with a monolithic app. So if you don't have, well, usually don't have the source code, but if you don't have more insight into the application, you won't be even able to containerize the whole thing. So in that case, you're dependent on what your provider provides you. So it's complicated if you're using off the shelf. Then do you have an example for incorrect microservice implementation? Well, incorrect is a vast word, but I'm coming to that in just a few slides, and I talk about that. Okay, Mahmoud. The Muhammad, oh yes, in a service provider, fail is not an option, but good to know a structure. Well, I'm not talking about failing in production. I'm talking about failing in your development process, setting up a certain way of developing from now on, and then seeing if that flies, if it fits the thing that you want to build in the end. Afterwards, for the rollout, you will never roll out something into production without having tested it and everything. So it's really about the development itself, about the development process, and why not afterwards test automation, stuff like that. Okay, good. So how do we identify? I really have to speed up. How do you identify candidates for transformation? Are there parts in the monolith that should scale differently than the rest of the system? Is there parts that seem tacked on really that just tell you, just rip me out and create the right microservice out of me? is there parts of the monolith that are changing much faster as the rest of us? And that's exactly the point, because if you take that part, transform it in the monolith, it can be developed separately with a separate release cycle. So you can, instead of releasing every 3 months the whole thing, you will still be doing that for the monolith, but something that needs to change faster can change faster independently of the whole system. Frequent deployments, we had that. Operates independently, yes, that's a large word. Subset of tables, data store. We will be talking about data in a second. And here we go. So when you transform your application from left to right, we see that in the graph, we have separate databases per microservice. Now, and you say that a failed microservice implementation or incorrect. A lot of people I talk about and with whom I'm doing the training, they think that containerizing their WAR file or their web application is meaning that they're doing microservices. It's not. It just means that you have containerized your web application. Well, the problem is, and here we're talking about what we call bounded context, and you can read up on that. You have the link to Martin Fowler's, which is one of the DevOps and so gurus. Just very, very simple. Bounded context is a pattern that we call that's included in what we call domain-driven design. Domain-driven design basically is looking at my data model and this and how you say cuts that into different bounded contexts. So if we take this example, for example, we have a sales domain that has territory, opportunity, whatever, but that uses customer and product. And we have a support domain that has ticket, defect, and so on, but that uses customer and product as well. So here we have a contact point. And what we do afterwards, we overlay those contexts, these boundaries, to identify single functionalities that might be covered with microservices. So here, typically, one for opportunity, one for ticketing. And then we have customer and product, which would be overlapping between the two domains, but which will be microservices that would be used by the two domains, by the microservices of the two domains. And that's something that that is used very, very often to have a look at how you can split your data model, because that's where it gets complicated. It's not complicated to create a container out of a web app. You can do that in a day, in a week, or perhaps in 2 weeks. The complicated stuff is to split up your database, your data model, so that each one of those services has its own data. Because if you don't do that, so we get a single point of congestion. Let me put it here. So you still have the coupling, this tight coupling that you have with your monolith. You still have it. You have it in the database. So if you want to add a new field, for example, in the database for data, if everybody is using the same database, you still have to coordinate those changes. You're not independent. If the database fails, everything goes offline. If a database for a single microservice fails, it's just this microservice that's impacted. It's difficult to scale again, and you have to use probably a relational database because that's what you had already. And if just one of the microservices needs a relational database, all the others have to cope with that. Otherwise, it won't work. You cannot mix non-SQL and relational databases. So it's really that's the absolute most complicated part of a microservice transformation is not the apps itself, it's the data model. So keep that in mind. And what we do afterwards is that we isolate, as I said, the data. So we go through this bounded context, identify the thing. And if you have visualization tools for your tables, for example, for a table structure in your database, you can do that and then just do an auto-organize. And then you probably will see like little clouds, little packs of tables that are appearing. And that helps, stupid as it is, it can help a lot on identifying where the different cutting points might be. So when we go from there to there, that's basically forbidden in microservice. So we have to split that. And what happens afterwards is that if I want to get the customer detail, for example, so I have the information about the customer, for example, like age and stuff like that. I have some account information in another one and address information in the third one. What happens is I call the first API this gets the microservice gets the information that it has in its own data set, and then the microservice calls out to the other REST APIs to get the information back. So you won't be calling those REST APIs. So that's obviously that's cool. We have this independence. So customer address, if I have to do an update, as long as I keep my API stable, I can do here and in my data model whatever I like, as long as the API is stable. So that's why we have to make sure that we have well-defined and well thought out APIs when we go into transformation like that. Okay, so we really have to define that first. So what's the benefits? Avoid unexpected data modification, because someone goes in the big central database and changes something, it changes for all the microservices. If I do it only here, it changes just for my microservice. We can make changes without blocking progress on other ones, so we don't have this single point of congestion. And we can use appropriate technologies. Let's say, for example, the customer details has a huge Oracle database, a relational one. Keep it. Just keep the stuff around that, the tables that you need. But perhaps the accounts, they would be better off with a non-SQL database where I can just pipe in my documents without caring about the exact number of fields and information that's in there. So I could be using MongoDB here and Oracle here, for example, which can be extremely interesting. And obviously more scalable, fault-tolerant, and flexible. We had that already. The drawbacks, obviously it's costly to refactor. And if already the microservice transformation itself is slightly costly, that's where the major part of the cost usually comes from. It's from remodeling, thinking about those contexts, remodeling, identifying where the microservices are, and then remodeling the data model. Okay. Next one, and we often don't think about that. What I showed you before, I'm calling customer details. Customer details calls out to customer accounts and to customer address. Now suppose that you have 30 microservices, which each one calls each other. That can introduce, if you have network latency, if you don't have your network latency under control, that can very easily and very rapidly introduce like half a second of latency. So again, question of architecture, don't make too many hops between the different microservices. Try to have microservices, but keep them flat as possible. In some cases, you need robust transaction handling. I'll be talking about that in a second. It's more difficult to debug, because if you call this one and you get an error back and it doesn't work, you have to be able to identify from which microservice or whatever subsystem this comes from. So it's more complicated, and that's why we have Kubernetes and all the stuff afterwards. Difficult to operationalize and more difficult to test. Obviously, those are I guess very clear. Now, just one word to the event-driven architecture. It's basically the same. It's just that we don't have REST calls, so we just have a REST call to get into the system, and then we have queues. So it will just post the query onto the queue. Customer address takes it and replies back when it's ready. So that's asynchronous functionality. And we have those ACID transactions, so to be sure that it has been delivered and so on and so forth. And if I post it once, it has been delivered exactly once to one service and so on and so forth. Because imagine we have this customer address service, we might have 100 instances of that. So make sure that only one of those is grabbing the request and responding to it and so on and so forth. So especially in banking environments and so on, we probably go through queues and not through direct REST calls. If asynchronous calls are important. Okay, good. Reasons not to use them, and I'm slowly getting to the end, a little bit late, but almost on time. If speed is your goal, don't use microservices. I mean, if you have real-time systems or stuff like that, microservices aren't your solution. You introduce latency and so on and so forth and so forth. Keep everything together in one block and you're good. So don't do that. If you have really tight integration, for example, between the components, again, that's more the real-time processing. Again, don't cut it up, because you will lose this real-time aspect. Then you have to decide at what point in this life cycle is it? Is it mission critical, or is it an old application that will be deprovisioned anyway in 2 years? Does it make sense, cost and benefit does it make sense to transform it? And I can tell you it's not always the case by far. If you have a moderately large, moderately complex application that's maintained by a relatively small team, why would you transform that? You won't get anything out of that. So really go for the low-hanging fruits, go for the most interesting ones, the ones that are producing, that are mission critical, that are critical for the business, that are really tightly tied to the revenue of your company. Okay, and not all applications are large enough to break down into microservices. Small applications, as again, it doesn't make sense to do that. So how do you detect anti-patterns? So if you start the microservice transformation and you see that when you change one microservice, you have to do changes to other microservices, then something's wrong. That's not good. It should be independent as much as possible. It's not always, obviously not always possible, especially if you have to change the API, but normally they should be more or less independent. So if you see that often, you know that that you have some problem with your architecture. If you have to deploy, if you're deploying your microservice and you have to deploy a whole bunch of other microservices at the same time with a certain version, you have a single point of congestion, you have a problem in your architecture. If your microservices are overly chatty, so if they're communicating a lot and sending a lot of data, that can be a problem, again, with latency. If you're in the same data center, it's not a problem, but if you start having afterwards your Kubernetes clusters and your containers spread perhaps even across different data centers, that can become a problem. If the same developers work across a large number of microservices, I'm not saying 2 or 3 different microservices, that's a possibility and that's not forbidden at all. But if you see that one developer works 10, 15 microservices, think about how you structure your developers and probably your squads or your DevOps teams, or perhaps it's a wrong architecture. If your microservices share a database, we had that, and if your microservices share a lot of the same code or models, obviously. I should do a break. I just wrap up. I have for 2-3 minutes, and then we should be good to go. And we have a break, and then go into the labs. Are you still there, Pascal?
Yes, we are.
Okay. So I think I fell off a cliff. It put me back on my Wi-Fi, and I think my French quality Wi-Fi just had a little hiccup. So should be okay now. So I was saying, I'm not sure if you heard it. We should break now. Let me just finish. I think I have for 3-4 minutes, and then we can break just before the lab. I think that's fair. Okay. Yeah. Good. Keep in mind, what works for large and complex applications does not always work at smaller scale. And what makes sense for a new application may not make sense for an existing application that you have to transform. Okay? Well, seems clear. And then I found that really hilarious. That's a guy who has a spreadsheet, and that answers a little bit back, I think, also to the question we had in Slack. Implementations or transformations that didn't work. Here's a lot of different links of examples where it didn't work. You see long live and prosper the monolith and stuff like that. So I stole a lot of stuff out here for my training. But have a look at that. It's really, it's frankly, there's some underneath them that are really fun to read. And if you want to see what not to do and why monolith might make sense still in certain cases, that's the way to go. Good. Questions? Let me take. Yes, Pascal, go and answer the door.
No, but there are some questions on the some comments regarding
take them in 1 minute. Give me 1 minute. Just 2 slides to finish that. Thing is, everybody loves containers, but if you go from the left with 10 containers to that what you have to the right, imagine you stake the containers as you would to the left. Just doesn't fly. So as I said, usually we start with one container, and that just a little anecdote, and then we wrap it up. When I started Docker and Kubernetes like 3.5 years ago, I was seeing a customer in Zurich, and they told me, yeah, we're starting with containers. With Docker, that's super cool. And we talked, and they were really super excited about that. And then I went back like 4 or 5 months later, and they had not 2 or 3 containers, but they had 150 containers. And they said, well, it's absolutely impossible to manage that now, because we have this concept of pets versus cattle. I don't know if everybody knows that on the call. Pets is my little cat, my monolith, obviously. My to it, I feed it and whatever and so on. And if my cat dies, if it gets run over or something, which happened with my cat lately, you're really sad. So if your monolith goes down, I can tell you production is really, really sad, and your sea level as well. On the other hand, we have cattle, which would be the containers. We have 4 chicken. Well, we had 5. 1 got eaten by a fox. Well, you buy a new one. It's not a biggie, okay? So that's the same with containers. A container must be built so that it can die and restart without any consequences for your system. So you don't want to handle that, because if you have 150, 2,000 containers, it's not possible, because if each time a container stops and restarts or crashes, if you get an alert, or if you go and investigate, you will get crazy fairly rapidly. So you cannot do that. And that's where Kubernetes comes in, because it helps us manage this complexity. Okay, so a container must be able to die and stand up. And then we can talk rapidly about monitoring, how you do that, different paradigms, and we'll do that next week. I hope you will be joining us, and it will be same place, same time. Just go within your VM, into the collector, into the lab environment, select Docker, begin course, and then you can start working through the different parts. So I'll be turning off my camera, go on mute, but I will still be here. I will be monitoring the Slack channel. Well, we will be monitoring the Slack channel. And what we will be doing, you have a first lab with the Docker basics, really simple stuff. You can jump over most of the parts because we already talked about that. Then you have the lab 2, working with containers. So you will build a Docker image, you will run it. Use a tool that's really cool called Portainer, which runs in a Docker container as well. So you can deploy that locally on your Docker instance, Docker engine, which helps you manage your containers, see logs, have a shell into the container and stuff like that. So really cool tool to use in a Docker environment. Then we'll deploy a slightly more complex Docker application, then push the image into the registry. And then I added lately a lab called Docker Internals. It's not the best title, but it just gives you the overview of over some Docker commands that might be useful for debugging and seeing what's going on and so on and so forth. So that's it. Well, it's not 90 minutes, it's 60 minutes. I have to tone that down. We'll be here until, well, for 1 hour, at least. I will be here for at least 1 hour still, monitoring the whole thing. And well, some reading tips, you will have that in the presentation. The links again, and if I don't hear back from you, hope to see you next week, same place, same time. Don't forget, Tuesday evening, 5 to 6:15, we'll have open mic for problems, for the demo, for the training environment, whatever, if you have questions to ask. And then we see each other, as I said, Wednesday, same place, same time, for the Kubernetes workshop. And with that, I thank you very much. And yeah, drop me a mail if you have questions, or ping me on Twitter, or yeah, or ask you questions in Slack. Okay, thank you very much for participating. I'll be going on mute now and trying to help you as good as we can for the next hour for the lab.